Hello, good morning, everybody. This is Michael from coachpilot.com. Coachpilot.com. I am an ATPL instructor. I've been teaching ATPL for students and for pilots converting their license to EASA for more than 10 years now. So here is my website. You can contact me at any time. You have the WhatsApp button here on the bottom of the page. If you are struggling with your ATPL, whether you are an ATPL student or an airline pilot converting his license from FAA or ICAO to EASA, just don't hesitate to contact me and I will help you. Today, from my holidays, actually, I wanted to do a short video about the meteorological situation. Because I have noticed that actually there is a particular situation over Western Europe. As you can see on this chart here, there is a low pressure system west of the UK, northwest, that is actually the previous tropical cyclone that was called Erin, that was integrated to the polar fronts, and that became a depression from the polar fronts, so a polar front depression. And we notice that there are cold fronts that are associated, so to this one in particular. And there is also another cold front here that is coming from a secondary depression that was present yesterday, that is probably disappearing right now. And if we go through the coming hours, we can see that probably, so today is the 28th of August and it's 12 o'clock UTC more or less, so we have that situation, and we see that probably at some point tomorrow morning we will have a secondary depression again with a cold front, particularly intense here, that is coming over the west coast of France. And that cold front will pass inland and with the weather that is associated. Okay, so what can we tell the students about that? Because there are plenty of students that are asking questions about meteorology, about particularly the part that is called air masses and fronts. What are the weather that is actually associated to a cold front like that is passing? So first of all, if we draw the situation a little bit, we can have a situation like that in which we have a low pressure system, okay, typically like that, with a cold front. So this one is a cold front in blue, like that, with the little triangles like that. This one is a warm front here associated, and all this system is belongs actually to what is called the polar fronts on the planet, like that. So we have one in the northern hemisphere like that, with low pressure systems like that, that is separating the cold air of polar origin like that with the subtropical air mass here in red on my little picture like that. So typically on that situation, this air is warm. This is called actually the warm sector. Okay, this air here is cold, and this one is cold as well. Okay, in front of the warm fronts. And so plenty of things happen when we have fronts like that. We have the isobars that are like that, like that, like that, like that, like that, like that. And actually, why I'm talking about that? Because there are plenty of questions in the ATPL syllabus that are associated with this type of situation. So here, I can show you an example. A cold front has passed. Okay, what weather characteristics can you expect? So the good answer is wind veers, pressure rises steadily, and occasional showers. Why that? So, okay, that's the good answer. Why that? We can explain that with actually the analysis of the situation that is associated. First of all, why the wind veers? Okay, because if we observe the situation, we have the isobars that are changing direction when the front is passing. Plus, we are in the northern hemisphere, so the wind is blowing anti-clockwise around the low pressure system like that. Anti-clockwise like that, like that. Okay, so if we analyze a little bit more in detail the direction of the wind before and after the cold front, that is this one, again, we can see that we have a wind here in the warm sector that is coming more or less from, let's say, 270 degrees, okay, something like that. And after the cold front, or after the cold front has passed, here we see on my little drawing that the wind is coming from 340, for example. Okay, so from 270 to 340, we can see that when the front has passed, actually here like that, the wind veers continuously. Okay, this is correct also regarding the warm front, because when the warm front is coming, you see that here the wind is coming from, let's say, 220 degrees, something like that, and after the warm front has passed, 270. So here you see the wind will have veered. Okay, first information, the wind will have veered. Okay, second information, if I come back, it's very clear on the situation of today. If I come back to the charts, like for example the situation that is expected on Friday at midnight UTC, you see clearly that between that part and that part, first of all, the wind will have veered because the isobars have changed direction. Okay, this is what we have demonstrated already. And second thing, what do we notice about the space between isobars? We see that here the isobars are much closer together as compared to this situation. Maybe we can find something a little bit clearer, like that. Yes, for example, you see here that the isobars are super close together, and here they are a little bit further apart. Okay, so what does it mean? It means that actually the wind will have increased in intensity and in speed. Okay, so I don't know if this is in the answer here, but actually it is something that would be an additional element. The wind will veer and will have the tendency to increase in intensity, in speed, once the cold front will have passed. Okay. Third thing here, the question asks about what happens in terms of precipitation, and we have the choice of occasional showers or continuous rain, basically. Okay, so why the good answer is occasional showers? Because very simply, actually, when we consider a cold front, if I draw the horizontal situation, the vertical situation, sorry, the side view of the situation, so this is the ground, like that, and we have a cold front that is arriving, that is pushing in that direction. Okay, so this is literally that part here, that is the front at the surface, like that. What do we have? We have an air mass that is very cold, that is arriving over an air mass that is warm, and that is obviously forced to climb at altitude. Okay, because the air mass has a lower density, and obviously lower density, the tendency is to climb above the cold air mass. Okay, so when it will climb like that, what is the cloud, typical cloud that is associated in that case? Convective cloud, okay, CB, TCU, and eventually CU also. Okay, then why after the cold fronts we have showers that are experienced? Why that? Because very simply, again, we have a cold air mass, and that cold air mass by definition arrives on a ground that is warmer. Okay, this is what defines a cold air mass. It's because the air is the ground is warmer than the air. Okay, so an air mass that is cold over a warm surface, what can happen? Convective activity, and convective activity always develop little cumulus like that. Okay, that can be bigger in some cases, but associated to this cumulus, the type of precipitation is always showers instead of continuous precipitation. So showers associated with this kind of clouds just because of the convective activity that is associated to the fact that the cold air mass arrives over a warm surface, as simple as that. Okay, in French, we have a specific expression to talk about that. We talk about un ciel de traîne, that refers to the fact that it's the air that is behind the cold front and that is associated with very good visibility, but associated with cumulus clouds and showers that last very short, but they are developed a lot behind these cold fronts. And that's it. This is how we can explain the question that is associated here to the presence of a cold front. So first of all, the only possibility is that the wind is veering, so you could already eliminate answer Charlie. Second, what happens to the pressure? We have not talked about it, but the pressure increases after the cold front. Okay, exactly for the same reason that the temperature is different. So in the cold air mass, basically, the air pressure is stronger. We can also demonstrate it with the isobars, very simply, like if I come back to my drawing and if I imagine that I am placed here like that, once the cold front will have passed, I see that gradually my pressure is significantly increasing when the cold front will have passed. Okay, so and that's it. And then the last statement was occasional shower instead of continuous rain. Yes, obviously. Why that? Because these showers are associated to convective clouds, so little cumulus that develop because of the physical properties of the cold air mass that is arriving over a warm surface, creating convective activity. And that's it. So I hope that this video can be helpful for the ATPL students studying meteorology. Don't hesitate again to contact me on coachapilot.com if you have any question, if you want to reinforce your level in ATPL theory, and just have fun with the ATPL and enjoy. Thank you very much for watching.